So, without further ado, let me introduce you to our first plenary speaker, Diana Liverman from the University of Arizona. Diana co-directs the Institute of Environment there, and she's going to be talking to us about the drivers of global environmental change. Diana Liverman.
Good morning. It's an enormous honor to address this conference and also to follow those young people who have asked us so many challenging questions. Let's start in darkness. This composite image of lights at night across the world from 2003 is a powerful representation of humanity as a planetary force in the Anthropocene. The lighter areas are associated with more energy use and are where people are concentrated in cities. Because most of the electric light is produced by fossil fuels, it also shows a geography of where pollutants and greenhouse gases are being emitted and in an increasingly urbanized world. The proportion of people living in cities increased from about 30% in 1950 to the pivotal day in 2010, when the balance tipped and more than half of us now live in cities. You can see the concentrations of light over Eastern North America, Western Europe, and Japan, the scattered lights across India and Eastern China. It also shows the clusters of human activity along the coasts, including in Australia, Latin America, and parts of Africa, and suggests the potential vulnerability of those populations to sea level rise. The theme of this conference is of a planet under pressure, and humanity is now the major driving force of global environmental change. Each one of us has an impact on the biosphere through our use of resources and the waste we generate, but some have a much greater impact than others. This photo is from the Live Earth concert in London a few years ago, and it reminds me of my own disproportionate impact because I arrived at the concert after an overnight flight from Johannesburg, contributing as much carbon dioxide in one day as an average resident of India does in a year. The contrast between rising individual consumption and slowing population growth is one of the key points of my presentation, where I've been asked to analyze some of the social driving forces of global environmental change. I'm going to begin with a brief review of the graphs of human activity that underpin the concepts of the Anthropocene and the great acceleration of resource use since about 1950. I'll then look at some important social trends in the last decade, noting signs of hope as well as reasons for concern. For example, I'm going to argue that population growth, often thought of as the key threat to the planet, is now slowing, and that energy use, while increasing, is doing so at a lower intensity. Demand for land is changing with the intensification of agriculture, reducing pressures on forests, but changing diets are putting new pressures on the planet. Trade in virtual water and carbon is changing geographies of responsibility for environmental impact, but may in fact reduce the overall effect. And although poverty has been shown to decrease, absolute and perceived inequality in incomes is increasing. I hope this will set the context for the talks by Will, Sandra, and Tony, and reflect some of the rich results from global environmental change programs that are going to be discussed throughout this conference. Here, from a recent paper by Will and colleagues from IGBP, is a set of graphs that showing significant increases in rates of change in human activity starting around the 1950s, illustrating how the 50 years from 1950 to 2000 were a period of dramatic and unprecedented change in human history. Don't worry about the detail. I'm going to look at some individual graphs in a minute. Just look at the overall trends, which go steeply upwards. Population increased from 3 to 6 billion in just 50 years, while the acceleration in economic activity was even more enormous, jumping 15-fold over that period. The post-war period has also seen the rapid expansion of international travel, electronic communication, and economic connectivity, and for those of you who can see the graphs, even of McDonald's restaurants. Here's the graph of human population growth, an indirect driver of resource consumption since 1750, where you can see an inflection point around 1950, rising steeply to around 2000 and after. What you do not see here is the slowing of growth as we moved into the 21st century, a tremendously significant trend. I would invite you to put a human face on population growth and consider the individual joys and sorrows that underlie a growing population. We know that people have children and large families for many reasons. This is a family from Samoa, including an essential human love of children and of families, the fear of child mortality, the role of children as family labor and security for old age, and the inability of women to control their fertility. But there's an important trend and a key variable that you should be aware of. Since 1950, the average global fertility rate, the number of children each woman will have, has fallen dramatically. It's halved from 5 to 2.5. The causes of this decline are multiple, but include jobs and higher incomes for women, especially in urbanizing areas, cultural changes, improved health and welfare for the elderly, and access to contraception. Millions of women have made a choice to have less children, and although smaller families may have slightly higher consumption per capita, this is going to reduce pressure on the planet. UN forecasts show fertility dropping below 2 by 2025 or so. Since replacement fertility is about 2.1, this means that population growth is starting to slow. It also means that there's a strong probability that population growth will level off around 9 billion and may in fact fall thereafter. Although 9 billion is a lot of people, it's a driving force that has turned a corner so long as we maintain the improving status of women and access to contraception, including in my own country, the US. It gives us a realistic target for efforts to provide water, food, and energy sustainably to this population. GDP, gross domestic product, is another variable that shows rapid growth after 1950. Again, this is an indirect driver, and translated into demand on non-renewable resources or waste, creates a great pressure on the planet. Although there was a slight dip during the financial crisis, reflected also in greenhouse gas emissions, according to the Global Carbon Project, overall growth of consumption is now growing again. There are also deep human desires behind the growth in GDP and consumption, including the fulfillment of basic needs through the growth of agriculture and housing, for the variety offered by a diversity of consumer goods, and the drive to accumulate wealth to pass on to our children. To these, we can add the fundamental characteristics of a capitalist economy, such as the search for profit, the promotion of consumption and constant upgrading of goods, and the resource demands of a militarized world. There has been a drop in the number of people living in extreme poverty worldwide, from more than 50% with under $1.25 a day in 1980 to only 16% in 2010. This means we met the MDG goal on poverty early. But of course, $1.25 a day means you're still very poor, and income is only one measure as poverty, as we'll hear during the conference. But although absolute poverty has declined, income inequality has increased as the incomes of the rich grow more than those of the poor. Inequality doubled from 1820 to 1992. The index of inequality, the Gini index, has increased from 0.28 to 0.31 today. Perceptions of inequality have also increased. As we have more mobility and a global media, many people know that they are poor compared to the lifestyles of the rich and famous. Let's take a quick look at energy now. Analysis of long-term data shows strong correlations between growth in GDP and energy consumption, with the use of energy also increasing steeply since 1950, especially of coal, oil, and natural gas. These fossil fuels produce the majority of anthropogenic greenhouse gas emissions. This poses important questions for policy. Can we shift to energy sources that have a lower environmental impact? Can we de-link economic growth from energy use? Or should we slow or reallocate growth so as to reduce overall consumption? There is evidence of a weakening link between GDP, energy, and emissions as economies become more efficient and switch away from fossil fuels. Since 1971, emissions per unit of economic growth, the carbon intensity of human activity, has fallen from 0.8 to 0.5 and continues to fall. Over the period 1990 to 2007, carbon dioxide emissions from energy use have decreased on average by 0.3% a year, although economic activity increased at more than 2%. China, one of the larger countries on our planet, has committed to reduce their energy intensity by 17% from 2010 to 2015, planning still to grow, but with much lower impact per unit of growth. The world's energy choices are also shifting, although slowly, in response to resource availability and cost, and to policy incentives and social preferences. These graphs show increases in installed wind and solar capacity worldwide. Other shifts include a renewal of interest in nuclear energy and a strengthening commitment to efficiency in many countries. Another important social driver is the demand for land and for food. This graph from IGBP represents the growth in domesticated land during the Anthropocene, that is, land that's used for pasture and croplands. It has a gentler slope than some of the other drivers, but it still shows a distinct shift after 1950, and that by 2000, more than 30% of the planet's land had been converted to human uses. There are, however, some interesting recent trends in land use that suggest a turnaround of deforestation in some countries. Recent research by scholars such as Eric Liverman and Patrick Mayfoy and Morton and de Vries show forest transitions and agricultural growth that's occurring without deforestation. The top row of these graphs is from Eric's work and shows expansion of forests in China, Costa Rica, El Salvador, and Vietnam, despite growth in the population and the economy. The causes of this transition include urbanization, agricultural intensification, and forest protection. But we should note that these researchers have also shown that in some cases, such as Vietnam, the forest loss has actually been displaced to neighbors, such as Laos and Burma. Morton and de Vries and colleagues' recent paper on soybean production in the southern Amazon shows that, in this case, soybean production seems to be growing by taking over pasture land, and that is not being displaced to cause more forest loss. However, in other regions, researchers are concerned that higher food prices and, for example, the reduction in conflict in Central Africa may spur new rounds of deforestation. Another indicator of human activity in the Anthropocene is the use of chemical fertilizers. This has grown from 50 to more than 300 million tons a year from 1950 to 2000. This allowed an intensification of agriculture that helped to feed people, but also, as we will see, had a serious impact on the biosphere. We see some fluctuation after 1990, and I'll take a quick look at this. But as we argue in an article that will appear in Bioscience, led by Ruth de Vries and Earl Ellis, fertilizer is one of several technologies that have increased food supplies, contributing to longer life expectancy, lower infant mortality, and more choices and opportunities to pursue our talents than at any other time in history. The planet currently provides enough food for an adequate diet for the entire human population, although this co-occurs with an array of environmental challenges, including biodiversity loss, nitrogen runoff, and changes in climate. That nearly 1 billion people remain undernourished without access to food is not the result of biophysical limits, but of social and institutional failure to implement solutions. It's also a manifestation of the tremendous amount of food waste we have in our societies, and demand for food is also changing because of changes in diet, where people are eating more meat and dairy, and that is intensifying the impacts of individuals. Fertilizer applications, combined with plant breeding and other inputs, is one reason why growth in global cereal production since 1950 has been driven by increases in crop yields, that is intensification, rather than expansion of crop area. Looking to the future, this trend spares land for nature and for biodiversity, but only if sustainable intensification can occur with less impacts on the Earth system. While agricultural inputs of fertilizer and water have serious local and regional environmental impacts, the latest data do suggest that nitrogen use is falling in regions such as North America and Europe, and is only growing very slowly now in South America. I could show several powerful animations that show how the timing and magnitude of these social drivers vary over history and geography. The problem with the graphs I've been showing you of social drivers is that they do not reflect the varied geographies of human activity on the planet, where some people and regions have a much larger impact than others. So I've got an animation here, if I can get it to work, that shows the geography of carbon dioxide emissions. Yeah. So what's this showing? It's from data from Oak Ridge that illustrates the history and geographies of carbon dioxide emissions since 1850. Starting from the Industrial Revolution in the UK in 1750, we could see emissions increase across Europe, then to North America and Japan by 1900. Remember, those emissions had a long residence time in the atmosphere. By the end of the 20th century, we have high emissions in China, India, and Europe and Eastern North America, but relatively little across Latin America and Africa. Here lies the core of the debate about responsibilities for climate change in relation to historical emissions. The main point I want to make here is that globally aggregated social drivers of global environmental change hide great variations in the role of different countries, but even more so different people within a country. A recent study in the UK showed that the emissions of the highest income earners are 3 times that of the lowest. In countries with high income inequality, the richest 10% of the population may be responsible for up to 50% of the emissions. And the growing middle classes of many developing or transitional countries are moving towards consumption habits that will add to the burden on the Earth system. Finally, let me mention trade. Recent research associated with several joint projects of the ICSU Global Environmental Change Programs has shown us that individual and country emissions, water and fertilizer use can be recalculated to account for trade, so that we can see how consumption of imports, for example, contributes to global environmental change, and exports might reduce the impacts of consumption in a particular country. This map from the Global Carbon Project shows the emissions embodied in products, showing how carbon is transferred from China to Europe, Japan, and the US, and from the US to Europe. Similar calculations show the transfer of water through trade in agricultural products. Countries become importers and exporters of virtual water, with US water exported all over the world. The total amount of water, however, if all of this food and agriculture had been produced domestically, would have been 2,407 cubic kilometers of water. Trade actually reduced the overall use of water, saving the world 369 cubic kilometers a year. So what we're seeing, and what the question we should ask, is for the global system, is trade actually reducing environmental impact in these cases, even though it would increase environmental impacts in particular regions? So to wrap up with my take-home messages, my argument is that humanity has definitely increased its use of resources and pollution since 1950. We have seen a great acceleration in human impact. But there are some signs that drivers are slowing or changing. Population growth is slowing and will level off. Energy and carbon intensity seem to be declining. Agricultural intensification and other factors are slowing or reversing deforestation in some regions. But many people still struggle to meet basic needs. Many of them see a profoundly unequal world, and many still aspire to increase their consumption. Many presentations at this conference will explore these societal trends in much more detail, and some of them may disagree with details of my own analysis. But I hope I've demonstrated the significance of social drivers and social science in understanding global environmental change. I do hope that this week, as we hear about the terrible pressures we're placing on the planet, you will also search for signs of hope, for planetary opportunities and reforms to Earth system governance. I also hope that you'll hear about the Future Earth Initiative, which is the opportunity to bring many of our research programs together to refocus our efforts on sustainability. Thank you very much. So, I should stay here?
Yeah. Thanks, Diana, for laying out those drivers. Thank you for sending in your questions. I think we've just time to hit you with one, if you don't mind. It's been texted in by someone who is nameless. Please tell us who you are when you send in your questions, so you can get the credit for it. this is it. Why is there so much focus on intensity when it's the absolute impacts that really matter?
Because if we're going to reduce impacts and maintain some level of consumption and lifestyles, we need to try to live more efficiently. So as the intensity reduces, whether it's the use of carbon or the use of water, we're living but with a lower impact on the planet. So that's why and what technology is doing in many cases is focusing on trying to make us more efficient so that we can reduce our impact and hopefully reduce our impact on the planet.
And hopefully eventually it affects absolute impact and absolute results too.
Yes.
But that's the first step. I hope that satisfied whoever sent in that question. Diana Liverman, thank you very much.